Okay, hello and welcome to the Toptal Academy for React.js, Lecture 4. My name is Vicente Verde and now let's continue. So let's do a little recap. We have seen a couple of things about React right now. So the first thing that we saw is that React is mainly just for views and it's not opinionated about how you're going to store your application state on models and controllers with like an MVC framework. React is just a library and not an entire framework, but it does have some opinionated data on how you're going to manage the data in your component, because we have these states versus props way of transferring data to our components. We have seen that it's much better to have a major component like a wrap component, which is the application, and that's the one managing the state. And it is better to transfer most of the data to other components just through props, right? If you want to go deep inside on React, I recommend you to go ahead and read the docs. There are not much to say about React. You can go to the guides and reference and tips there in the docs just to get a deep knowledge on React. We are mainly going to focus on most of the libraries and frameworks that are surrounding React, like tools and other stuff. So as we saw last week, we have our first component, which is React Router, which allow us to load different components depending on the URL in the browser. And it was loading as children of our application, so our application is no longer in control of which props it can send to internal modules. So mainly what we did was to make every model to be in charge of their own state, and then instantiating components with only sending props. We have these components that may handle the data inside, but that's a particular situation depending on the component. Basically, how can we move again the data to be managed just by the application using the router? Well, we know that React allows us to send data to elements in two ways, through props and through states. And it's basically receiving data from the parent element or the parent component only through the props, and now with the React Router we are no longer in charge of the props that our models are receiving. So there is a third way, and we talked about this a little bit in the last lecture, and it was using the context. The context is mainly the third way to transfer data. It is not safe to use it in every application in a production environment, because it's mainly there for frameworks and library to help you with using the content, which is exactly what we are going to do with this architecture for handling our data. So we have Flux. Flux is mainly an architecture. We are always going to find this chart, this diagram about how Flux works. It doesn't say much by simple looking at the diagram, which it's comprehensible that it should be explaining itself, but it's not completely understandable just by the first look. The main idea here is that Flux is going to allow the views to generate an action, and those actions will go through a dispatcher, and then the dispatcher will notify the stores to modify themselves, and then the store will notify the view that some changes are happening inside them, so it perhaps needs to be re-rendered. So as I said, Flux was presented a year after React in 2014, and it's not an implementation, it's just an architecture, an idea on how Facebook is saying that we should implement the state imitations for a React application. It provides the unidirectional data flow, so it solves the MVC problem that we talked about on the first lecture, about that maybe we have a model that is connected to a view, it is notifying the view to be re-rendered, and then the view is modifying the model, and the model might modify other models, and that kind of stuff that makes an application state completely untraceable and generates a lot of bugs. So the unidirectional data flow inside Flux is solving that problem, which is awesome. And as it is not an implementation and it's just an architecture, we can find several implementations of Flux out there. Mainly we have Redux. We have now an implementation from Facebook, which is Facebook's Flux, but if you take a look at that, it's mainly just the dispatcher, and it's not opinionated on how you are going to implement your stores and your actions and stuff. We have Reflux, Marty, McFly. There is a lot of references to Back to the Future here, because mainly, I guess, it's for the Flux capacitor. If you want to take a look at this video that I'm putting the link here, it's about different strategies to manage your state mutations in React applications. It's really interesting. It's from the ReactConf 2016, so I recommend you to take a look at that. So I'm going to take an inspiration from this site, Code Cartoons. It's an interesting site because it's mainly trying to explain complex architectures like Flux in this case by using cartoons. So it is really interesting, and I strongly recommend you to check after this talk. Now we have like a new character here, which is the action creator. So we're going to try to explain how Flux works by connecting the view through the action creator, which is going to generate our action, and that's going to go to the dispatcher and store and so on. So first, let's try to describe what an action really is. An action is a minimal description of the state mutation, which means imagine that an action is just a plain JavaScript object, which is going to have a type and a payload, and on the type is going to describe which kind of mutation we are going to perform on an state, and it doesn't actually perform the mutation, it just describes the mutation. So that's an important thing also. And actions are going to be created mainly through action creators. Even so, they are just plain JavaScript objects, and you can dispatch just by creating your own action. It is recommended to go through action creators because, as we are going to see in further lectures, they can get a bit more complicated. So understanding this, the view is going to have reference to the actions creator, knowing all the kind of actions that it could trigger, if we can say it like that. So it's going to call the action creator for a specific action, and that's going to go to the dispatcher. Now, the dispatcher is going to receive the action from the view, and it's going to send it to all the subscriber stores. So think about this like the dispatcher is a main place where all the stores are subscribed, and every time that a new action arrives to the dispatcher, it's going to automatically notify all the stores about all the actions. The dispatcher could also set dependencies, because sometimes you need a specific store to finish its process before starting the modifications or the mutations on another store, so you can set dependencies directly inside of the dispatcher. Continuing with our diagram, we're going to go to the store, and finally the store is this object that is going to actually perform this state mutation. As I said, it's going to receive all the actions, so it will need to filter the actions that are specific for that store or for the data stored inside that particular store. And then it's going to notify the views. Maybe a couple of views will be having a reference to specific stores, so it's going to notify only those views. This is in a Flux architecture. We're not going to see an implementation of this kind of architecture because we're going to focus on the Redux implementation of Flux, which is inspired, of course, by Flux, but it's a bit different, and it is like the de facto standard implementation currently for React, and as we're going to see for other frameworks as well. So Redux works in the same way. I also added here a link for the cartoons explaining specifically how Redux works. And so we can focus on the same thing, but now we're going to be an implementation of how the view actually calls the action creator, and then everything starts from there. Basically, Redux is a predictable state container for JavaScript applications. Notice that I'm not mentioning particularly React here, which means that it could work with any other framework that you want to. It ensures the consistent behavior of your state, so that's make it predictable and avoid this problem of multiple models calling each other and mutating this state. And it allows some interesting development experience, which are hot reloading for the code in the stores, and time traveling. We're going to see what are they in the course of other lectures. Redux is based on three main principles, which are Redux is it's going to be always the single source of truth. The state in Redux, it's read-only, so you cannot modify the state directly. And changes are made using pure functions. This is the most important part of Redux, because as we are going to see, those pure functions are what we call the reducers. So let's take a look at each of them. The single source of truth is because we are going to have only one store, which it's going to contain our state, which is just an object tree, a simple plain JavaScript object. We're going to have this object with properties that are serializable and iterable. Serializable, it means that it could be serialized, for example, to a JSON, so it cannot contain any dynamic information or pointers to itself, etc. And iterable because as it is serializable, you could initialize your Redux store, for example, on the server, and mutate whatever you need to mutate on the server, and then send that serialized version of your state directly to your client as a JSON, as a string. And then inside your client, while you are initializing your application, you can iterate your application with this JSON received from the server. That help us to make this server-side rendering and initializing the application from the version in JavaScript and the client. So it's an interesting property. And for free, we get undo and redo, which are features that are often sometimes it gets complicated to implement. So it is really interesting how Redux help us to have this feature as well. The state is read-only, as we said. This is the second principle, because all the mutations are going to go through an actions only, and even the events coming from the view, from the user, or from the network, they cannot mutate the state. They are going to dispatch an action in order to mutate the state. This is what makes Redux a bit complicated, and we're going to look how to connect the server on the next lecture. And that's the property that the state is read-only. It makes it immutable, so every time you want to change the state, you have to create a new state. So the last principle is that every change is made with a pure function. So the reducers, as I said, are pure functions, which means that they cannot operate on anything outside of the function. So we cannot make network calls, we cannot modify the state of a global object. We can just modify the things that we are receiving, right? And we are returning the modified state. In this case, we are going to be creating copies of the state and then mutating the copy and returning the copy. Pure function also ensures that if we receive exactly the same parameters, we are always going to return the same result. So to make it look like reducers, we are going to always be receiving the current state plus an action, and then the reducer is going to perform the mutation and it's going to return us the new state, which means that for every action that we have on our system, we are going to be generating a new state object with the new state, containing the new state in the store, which is the thing that is giving us this time traveling across all the operations that were created in the application or the events. We're going to be able to record an entire user session and maybe later run it as a video just by sending the actions in the same order to the reducers and let them mutate this state. We're going to have the undo and redo, because we can save all the states, intermediate states, in after the action has complete the reducer execution. So we will have like several copies of these states depending on different times in our application. So let's see an example of this. We're going to see how Redux can be actually used without even having Redux. So I'm going to create a simple JavaScript application here without React. It's just going to be with an initial state having a name. In this case, it's going to be Vicente Verde, and another property of our state is going to be count, which is going to be our counter, and it's going to be initially set to 0. We are going to have one reducer, which is this function that takes an state and an action, and it will return our new state. So we are using here the default syntax of ES6. So if we are not receiving a state, or if we are receiving undefined for the state, which is what happened for the initialization, we are going to return our initial state. So this is going to be returned the first time that Redux call our application reducer. We are going to initialize that to initial state. Then we're going to be receiving the action, And in this case, this reducer is going to be considering only these three actions: increment, decrement, and change name. As you can see, say that actions can have a type and a payload. So in this case, we are doing a switch across the type, and then we are comparing that with the string to see which type of actions it is. And as we are returning always a new state, we need to create a copy. We are going to create a copy of the current state using the object.assign, which is going to create a new object, and it's going to merge that with the current state. And then we are going to overwrite, in this case, for example, only the property count with whatever was on the state before plus the action payload. And for decrement, we're going to use minus instead, of course. And for change name, we are directly going to assign the name of the new state to the action name, which in this case is going to be the payload. The only property required for an action is type. The payload could be on any property. You could use a payload property and set an entire object there, or it's left to you on how to want to implement the payload of actions. And after that, if we are not listening for a particular action, we are just returning this state without any mutation. So Redux provides a couple of functions. We are going to use create store right now. You just install it with npm install Redux. In this case, I have it just installed through my package.json. So you're going to be able to run npm install and install everything here. And we're calling the create store, and it receives the reducer that we are going to use to mutate our state. So with that store, in this case, we are, just because we are not using any framework, I'm just receiving a reference to our start element, the same that we are using. I just added a couple of HTML lines here just to have some elements to perform the mutations. In this case, it's an input with type text and buttons for increment and decrement. So our rendering is our render function is just going to render the JSON stringified version of our store get state. We don't access the state directly. We just ask the store to give us a reference to the current state. And then we're going to call render to render the initial state of our application. And then we are going to subscribe to our store the render function. So this means every time that we are mutating our state, the store is going to call all the subscribed functions, which in this case is going to be the render. So it's going to re-render the state of our application. You can compare this as the way that Flux were notifying the store is notifying the view. So Redux is allowing the functions, the render functions, to subscribe to the store. So let's go back there. Perfect. Now, for the actions and to perform the mutations, we are going to define a couple of action creators. You can see here that I'm going to define an increment1 function, which is just a simple function that returns an object. This object is the actual action, and it sets the type to increment, and in the payload it sets the 1. This object, it could be sent to the dispatch directly. I don't have to go through action creator, but it's just to understand the pattern that we are going to need to use for Redux. Now I also implemented the same version, but in this case receiving the amount for the payload. So now it is understandable why I'm using a function to generate my action instead of just sending the action. And the same thing for decrement and for change name here. I'm just receiving the name and setting that as the payload. Now, if we take a look at our application, we just have our current state of the application rendered up there. I'm going to zoom this a little bit. There you have. And I'm going to expand this as well. Okay, so we have our an application state, and our buttons are an interface to perform the mutations on our state. What's going to happen, I'm subscribing here a listener for the click events. In the case for increment, I'm just calling the action creator increment1, and I'm sending that to the dispatch in the store. Remember that in Flux we have a dispatcher which was separated from the store, because in Flux you can have multiple stores. As in Redux you only have one. The dispatch is just a method on the store. So when you dispatch an action, you tell your store to dispatch that specific action. In the decrement button, we are sending the payload, in this case as an argument to the decrement function, to the decrement action creator function, and we are dispatching the result, which is going to be an action with that decrement. And for change name, we are doing the same, but in this case we are getting the value of the text field. So let's take a look at how it works. So if we increment, we can see that our rendering function is automatically rendering how much our state is changing for specifically for counter. And decrement, we can change the amount of decrement here, like 3. So let's re-render that, and it's going to be incrementing and now decrementing by 3. Perfect. And now for the name, now I can set anything on the name, and when I hit change name, it's going to change our state. That's basically it. It's to demonstrate that Redux could be used without any framework. You don't need React or nothing to start using Redux. You can just grab it and start to code with your own framework if you want. So there is another property that I want to show you here. As we can see here, this application reducer, it's giving us the idea that we are going to have only one reducer. That's true, you are going to have only one reducer, but it could be a composed reducer. So we have this function, which is combine reducers from Redux, that it's going to allow us to create one reducer for each property in the state. So we're going to see how that works. We're going to define a name reducer and a count reducer, which are going to take care of the state as if the state of the application were just only the value inside that key. So for name reducer, we are going to consider that the state is the string picante verde as its initial value, and we are returning any mutation for that particular key. So for the count, we are doing the same. Here I have it fixed, so it should be action.payload and action.payload. Perfect. And now, how do we tell Redux that we want to use this reducer for the name key and this reducer for the count key? Well, here's where we use these combined reducers function from Redux, which receives an argument that is an object where you say the name of the key, in this case name, and the reference of the reducer, in this case name reducers. So same thing for count reducer, and let's take a look at that. There we go. And as you can see here, it is still working, so our application is still go. Okay. So also, thanks to ES6 notation, we can name our reducers with the same name of the key that we want to modify, and then we just could do this. It's going to be much comprehensible what's going on. There it is. So perfect. Everything working. That's it. So that's basically Redux. It's super simple. I encourage you to give it a try. Don't hesitate to ask me any question about it, because sometimes it might get tricky to understand what things go in which place. So the most important thing is that Redux is a predictable state container for JavaScript applications. So we can connect Redux with any kind of JavaScript application. And Redux itself, it's providing us bindings for different UI frameworks. For example, for React, of course, we have React Redux bindings. For Polymer as well, we have the Deku Redux. It's actually one proposed by the Redux page itself. But if you want to try, you can even use it with Angular 2, or even with Backbone. So the important thing here is that learning Redux is not only for React, but you can apply Redux. If you are facing any problems, for example, with Backbone collections and models, you can maybe start your migration to React just by migrating the collections and models to Redux and starting from there. So now for the final part, we're going to see how this React Redux bindings works. It has a different differentiation between container components and presentational components. We're going to refer to this as two separate kind of components made in React. The container components are the one that know about Redux. They are going to have the references to the action creators, and they are going to map the state from Redux to props in our presentational components. The presentational components are the normal components that you write. They don't need to be to have any reference to Redux or to the binding React Redux, and they are going to be almost automatically written by Redux, React Redux bindings. We're going to see how to use the provider and to configure the store and the reducer. Well, as long as we solve for using Redux only, it changed a little bit when we are trying to use it with React. So the first thing that we have to take into account is, of course, installing the React Redux bindings and Redux itself. I am going to use the same application from last lecture, but we are not going to contact the server yet. I just want to show you the mutations of local state using Redux. And then on the next lecture, we're going to get into middlewares and other parts of Redux. So after installing the React Redux component bindings, we're going to change our index. So we're going to grab the entire router with a provider, which is this element provided by the React Redux bindings. And this receives as a prop the store that we're going to have for our entire application. And here we're going to see how to configure our store to make it work with our application. So I just created a store file there in the main directory, in the source directory of the application. which is going to use the create, store, and the combine reducer functions from Redux, as we saw in the simple Redux sample. And I'm going to receive all the reducers in another file. For this simple case, it's not needed, but as we are going to make this application grow in the course of the next lecture, we're going to use this code as a base for the next projects. So here I'm just returning the creation of the store using just the combined reducers from the reducers file. So my reducers file is just an export for, in this case, the person. I'm using the ES6 notation. So I'm receiving the reducer from the person's reducer. I have this organization for my files. Redux doesn't require you to organize in this way. You can do it as you wish. You could use I don't know, folder for modules, and inside you can set the components, the actions, and the reducers for each module. That's fine. Or you can have like in this case the components and the actions separated on different folders. So let's take a look at the person's reducers file here. The reducer, let's check first this part, is just a simple function, pure function that receives the state and the action, and depending on the action is going to perform the mutation, which in this case is similar to the first samples that we have. I'm just doing the slice trick to create a copy of the array. I have that as the initial state here on top of my reducer. So if for the first call of the reducer, the state is going to be set to undefined, so I'm going to return my initial state. And for the different action, in this case, I'm defining constants in the actions file. We're going to see that later. But for persons add, it is just creating a copy of the array and then pushing the person coming in the action. This would be like the payload, and then it's returning the new state. So here we can illustrate clearly how Redux works. We have a state, our current state. We are creating a copy, and we are mutating that copy. But we have both states, and maybe Redux behind the scenes is saving a copy of all the different stages of the state in the course of a session of a user using the application. Then we have here the edit action, which is going to modify a particular person on a particular index, and then the del action. So after this, we're going to see how the actions works. Here in this file, I have my actions creator and my action types exported as constant. This is this is not required, but it's commonly to use it this way to define the constant instead of just the strings. So in this case, I just have 3 action creators, which are add, edit, and del. So they are just responding with the action object with that specific type and all the payload that is required. For example, for edit, it is required the index that I'm going to edit and the new person that I want to save on that index. So that's it. That's mainly the connection between React and Redux. But now we have to understand how our components in React are receiving these references from Redux. So what I did first, I took my screen elements and I changed them so they are receiving everything they need through properties. In this case, I am receiving an add function to be called whenever a person is added through the person form. This is pretty similar to the first samples. For editing, I am receiving the list of the persons to edit because I have to initialize the component the first time it renders. And then also I'm receiving an onEdit function to perform the editing of the person. And in the parameters, this is because of the React router, I am receiving the index that I want to edit. So when the component did mount, I'm going to search on my persons list the index coming from the React router, and then I'm going to set those values as the initial values of my form. And for listing, particularly listing is not performing any kind of mutation in the data, except that this list screen also have the delete the selected index. So it is actually receiving the function undel, and it's mainly receiving the person array to render the list. So we are connecting everything like we did it before, and we are using the context to contact the router, and that's pretty similar to the version before. So now that we have that, we are going to need a container element that wraps our React component with the Redux framework. So what we're going to do is for add, for example, we're going to use the connect function provided by Redux, which is a high order element, which means it's going to modify our element, and it's going to create a new element based on those modifications. And this connect functions receive two arguments, which are mapped state to props. It is a function that receives the entire state of the application and allows you to return an object which are going to be set as the properties to your wrapped component. In this case, for add, I just need don't need the person list, but it's just like figurative here. So I could grab the person's key from my entire state and send that as the person properties. Now the second argument is much more important because it's the dispatch to props. So here I have my reference to the dispatch function of the store automatically injected in the connect function by Redux. So I can send the onAdd property that is the add screen is expecting as the let me split my screen so you can see it right here. There it is. So my screen is expecting an onAdd function, and I'm modifying here on the container. I am modifying the dispatch to props objects to return in the onAdd key a function that receives a person, and then dispatch the add action creator sending the person. As you can see, I'm here importing the action creator from my actions file. This is a bit tricky on how Redux made us to connect things. Finally, I'm creating my component, which is going to be called add container because it's the component that is containing Redux and my actual components. And I'm going to call connect, which is going to generate a function that receives the component that I want to wrap with the React Redux bindings. Then I'm going to return that, and if you see here in the index what I'm actually sending to the router, it is my container elements. This list container, add container, and edit container. I did the same thing for all three. So it's just wrapping my screen with all the Redux references. Why I'm doing this on separated files? Yes, I could go ahead and take this screen and add all the references here on top, import the connect React Redux, and then receive all the references to my actions creators and my constants for the action types and etc. But that would be creating a dependency on my screen from Redux. So as Redux wants you to be decoupled from your component, you can just separate your containers and have them on different files in this way, and this will allow you in the future, if you want to change your state mutation framework from Redux to anything else, you can just go ahead and edit these containers and not modify your entire application. So that's pretty much it, and I hope it's not much. If you have any doubt, just ask on the Slack channel, and you can review as well the documentation for Redux. In the next lecture, we're going to see more advanced parts from Redux in order to contact the server through. Okay, hello and welcome to the Toptal Academy for React.js, Lecture 4. My name is Vicente Verde, and now let's continue. So let's do a little recap. We have seen a couple of things.